Okay, in each of the following reaction we have to basically write down the product that is possible. So first question we have, that is if I have CH3 and CH2, there I have C double bond O, and then CH2, C double bond O, OCH3. Now the reagents used are, so first reagent is NaOMe, so Na plus OMe minus, so this will act as a base. Now the second reagent acting is CH3I, and third reagent is H3O plus, and heating is also there. So you have to write down the final product. So let me give you 1 minute time. I think all of you can do this one. Okay, so if you have understood, let me do this one. So in the first step, you can generate a carbon ion from here. And once you have generated the carbon ion, this carbon ion will attack on CH3I. This is a nucleophilic attack. So after the first reaction, you will have CH3 attached here. Now if you do hydrolysis, this side you have ester. Ester will be converted into acid. So you will have something like this. Before heating, you will have CH3, CH2, and there you have C double bond O, and now CH. This CH3 will be attached on this carbon, and then you have COOH this side. Now if you see, this is a beta keto acid. So this is a alpha carbon, this is a beta carbon, and this is a beta keto acid. So at beta position of a keto group acid. So beta keto acid easily decarboxylate, everybody knows. So if you heat this compound, decarboxylation will take place and CO2 will release. So you will have CH3, CH2, CO, CH, CH3, and here you will have a decarboxylation, CO2 will release, and you will have only hydrogen, so CH2 will be there plus CO2, and you have one product that is coming from here, CH3OH, that is we have already said this is a ester. Hydrolysis of ester will give you acid plus alcohol, so one product you will also have CH3OH. I think all of you are able to understand. Let us do the next one. So B part we have, so this is A part. Let us do B. So in this part we have this. So this is a alpha beta unsaturated carbonyl compound, this plus. Now let me write in terms of bond line diagram, so it will be easy for me. So I am writing in terms of bond line diagram. CH2, then again I have CO, and this side I have OET, and this is treated with a base OET minus. So first reagent I am taking OET minus, second is H3O plus, that is hydrolysis, and third is basically heating. Are you getting? So you have to write down the final product in this reaction. So first is easy one. You can OET minus can act as a base. So let us try using OET minus as a base. Now this carbon is a nucleophile. This will act as a nucleophile, and I will also suggest you do basically conjugate addition. So carbon nucleophile generally adds in a conjugate addition. So this will be a type of Michael addition. So I am giving you a hint. So this is a Michael addition. So let us try to write down the product. Okay, let me tell you. So you will have minus carbon and first here. So after the first step, I will have a carbon ion here. This minus. Are you getting? Of course, there is a hydrogen, so I am not showing you the hydrogen. Now this minus will attack on, let me write this molecule as something like this. Same molecule I am writing like this. Now this will attack on this carbon, this bond goes here and this goes here. and I can take H plus and the corresponding things if I do. So I will have double bond O, OET, and this position you have this carbon attached. So this carbon and this carbon is connected. So let us say, let me draw something like this, and let me number. So this is carbon number 1, this is 2, and this is 3. So on carbon number 1 is connected, this is 2, and on carbon number 3 you will have O minus, that will be finally converted into OH. And between carbon number 2 and 3 will have a double bond. So this is carbon number 3. So you will carbon number 1, 2 and 3 will have a double bond. Now this compound, now further if you heat, basically you hydrolyze, this is the second step, hydrolysis H plus. Now two things will happen. This ester will hydrolyze and it will give you acid, and there is a ketoenol tautomerization that is also possible here. So I can write after the tautomerization and acid formation, so we will have COOH, and this side we will have, after tautomerization you will have a ketone. Are you getting? Now if you heat, this is again beta keto acid, so this is alpha carbon, this is a beta carbon. If you heat this compound, are you getting? If you heat, it will lose CO2 molecule. So let us write the product after loss of CO2. So if you lose CO2, the product will be, so this CO2 is gone, so you will have hydrogen here, and this side also, so you will have, this CO2 is gone, so this carbon is basically gone. So this carbon is connected to only 2 hydrogens, there will be no carbon. So let me put hydrogen here. Are you getting? So this carbon is gone, CO2 is gone, so you have this compound. Are you getting? So I will have this. Here is a double bond O. Are you getting or not? I can write the same thing in a better way. So I will have a double bond O here. And corresponding carbon number 3. So this is carbon number 3. You will have CH2 and COH. So you will have CH2 and then COCH3. So this is the final product you will get. If you want, you can write in bond line diagram also. So you will have double bond O, and then you will have CH2CO CH3. So this is the final product you have after this reaction. And one product you will get is CO2, that is the decarboxylation. Another product you will have, that is ETOH, that is a hydrolysis of acid. So you see, if you do hydrolysis of this, you will have another product ETOH. I think all of you are getting this one. Let us discuss the next one, C part. So C part says, this is the easy one. So you have this side. Now there is only one alpha hydrogen. So this side you have Me. This side you also have Me. This side you have hydrogen. This side PH. Now this is treated with LDA, lithium diisopropyl amide. So this is treated with lithium diisopropyl amide. In the next step you have CH3, CH2, CH2Br. So this is easy one, everybody can understand. So in the first step, this will take this alpha hydrogen, I have only one alpha hydrogen, make a carbanion, this carbanion will attack on this alkyl halide, so this goes. So the final product in this reaction you will have. So let me write something like this. So if I'm write my Me this side, and this C double bond O this side, and PH, and H will be CH2, CH2, CH3. So hydrogen will be replaced by CH2, CH2, CH3. Now let us discuss the D part. So we have the D part, and this says, this is a basically Wittig reaction, PHC double bond O, and here I have a cyclohexane ring, and this reacts with PH3P, and this is plus, this is CH lone pair you have minus, and then CH2 CH3. So what will be the product in this reaction? Now I will give you a hint, this is nothing but Wittig reaction. So if you remember Wittig reaction, we can write down the product. So what happens with the British reaction, this CO bond, basically I can connect from this. Are you getting or not? So this is CO bond will convert it to double bond CH2. So I will have PH C double bond, and now this will be attached here, that is CH CH2 CH3 CH CH2 CH3. So you will have this. Now this side you will have a cyclohexane ring. Are you getting? So this is the product after the British reaction. So let us discuss E part. So this is a something like this you have. So double bond O CO CH3 O CH3 OMe. Now this compound is treated with NaOMe. So first you have Na plus OMe minus. So this will act as a base, and then you have CH3. This is the easy one. So you have 1 2 3 4 carbon, 1 2 3 4 carbon, 1 2 3 4 carbon, and here you have Br. Now what will be the product? So everybody knows you will make a carbon ion here. So you have alpha hydrogen. Make a carbon ion, attack this here. So you will leave Br. So the final product in this case you will have double bond O, and now this side you have CO OMe. But now this side you will have 1 2 3 4 carbon. So 1 2 3 4 1 2 3 4 carbon. Are you getting or not? So this is the easy one. Simply you have to make a carbon ion, and the next step carbon ion will attack on alkyl halide. Now the next question, F. So this says what would be the product if the product of the previous reaction, that is this, on this side you have COOMe, and this side you have 4 carbon. So if this compound is hydrolyzed and heated, so what will the final product? So this will first give you acid COOH, and now this is a beta keto acid. So this will decarboxylate. So you will have simply this molecule, and here you will have 4 carbon. Are you getting? Okay, I think all of you have copied this one. We'll discuss the next problem.